this video, we're going to talk about the law of sines. So we're going to start with a little bit of background. So we use the law of sines because sometimes we have triangles that don't have right angles. So many of the triangles we've seen up to now always had one angle that was 90 degrees, and so that allows us to use things like Pythagorean theorem, which is really nice. But when we have a triangle that doesn't have a right angle, which we call an oblique triangle, we have to use a few different tools. So in this section, we're going to talk about the law of sines, and in the next section, we're going to cover the law of cosines. Okay, so when we talk about two triangles being congruent, that's kind of the focus of the law of sines. So we have four cases where two triangles can be congruent, and you might remember these from high school geometry, maybe not. So the first one, we might have an angle, a side, and an angle, or a side, an angle, and an angle. So anytime we have these little abbreviations for the different cases, basically what this is saying is if two triangles are the same or have blank, blank, blank the same, so we have a bunch of combinations of A's and S's basically. So if it has those things the same, then the two triangles are congruent. So in this first case, it's if we have an angle, a side, and an angle, or a side and two angles. And so I have a couple of pictures here to give you some examples. Another one we could have is a side, angle, side. So notice here we have the side, then we have an angle, and then we have the side. So if two triangles have those two things the same, or those three things the same in that order, those two would also be congruent. And finally, we have the case where we have all three sides, the SSS. So if two triangles have all three sides congruent, then we only get, or both of those triangles would be congruent, sorry. But then finally we come to the case where we have side, side, angle. And so your geometry teacher in high school might have told you if it spells a bad word, then it's not a congruence property. And so that's a nice little way to remember it. So that's also why I've written it in the order SSA. But anyway, so in this case, we actually don't get congruence. So in this case, we may have two triangles that are not the same. And sometimes you may hear this called the ambiguous case because you can get a few different things that happen. And we're going to talk about those in a little bit, but we're going to start with the first three cases first. So one other thing to talk about is why can't we have angle, angle, angle? So we have all these combinations of A's and S's, and some give us congruent triangles and some don't. But why can't we have angle, angle, angle? So if we know all three angles of a triangle, or of two triangles, does that mean that they're congruent? And the answer is no, because we could have two different triangles that are different sizes, but the same angles. So we could have two triangles with the same angles, but they could be different sizes. So an example of this would be, let's say that we have like a little triangle that looks like this and a big triangle that looks like this, and maybe the angles are the same. So like, well, maybe I won't write examples in there, but anyway, you could have two triangles that look exactly the same, but like one is scaled up or down from the other. So these are what we call similar triangles. So instead of congruent, we just have similarity. Triangles. Oh, is my eraser not going to work today? There we go. Okay, triangles. All right, so those are basically all the different cases we could have. The first three cases, if we have two triangles with all of those things the same, then those two triangles are congruent. In the fourth case, if we have two sides and an angle that are the same between two triangles, the two triangles may be congruent, but not necessarily. And then finally, three angles, they may not be congruent, but they will be similar. All right, so finally we come to the law of sines. So like, why do we need the law of sines? Well, when we have all of those different cases, you notice we have sides and angles. So the law of sines is going to help us relate sides to angles. So in any triangle ABC, so I've got my triangle drawn here, and the way we typically label this is across from the side, we label the angle with the capital letter. So like across from side A, we'll have angle A, across from side B, we'll have angle B, and across from side C, we'll have angle C. So in this arbitrary triangle ABC, we have the following relation. So we can say that the sine of big A divided by little a is equal to the sine of big B over little b is equal to the sine of big C over little c. So that is the law of sines. So you'll notice that you have two different equal signs, and so it's kind of weird that you have three things set equal to each other, but when we work problems, we're going to pick two side and angle pairs at a time. So I'm just going to make a note of that. So pick two sides, angles at a time. And it's just going to depend on your problem and what information you're given as to which ones you want to pick. So we're going to practice by solving the following triangle. So I believe we talked about in a previous section that solving the triangle means to find all three sides and all three angles. Okay, so in this triangle we have side B, I'm guessing, because A and C we don't know. And you'll notice sometimes we have Greek letters written across, but I'm just going to change this to a big A so that we don't get confused. So I have my triangle ABC, and my angles are labeled across from the corresponding side. So what we need to find are angle B, side A, and side C. And so what I like to do is write my answers as a box off to the side of like everything that's in the triangle, and then that way I know what I need to find. So in my triangle, I have side A, side B, and side C, and I have angle A, angle B, and angle C. And so I'm going to go ahead and fill in everything I know, and that'll leave me with what I still need to find. So I know that angle C is 43 degrees, I know angle A is 98 degrees, and I know that side B is 22. So now I need to find side A, side C, and angle B. So maybe the easiest thing to start with is angle B. So in a triangle, we know that all three angles should add up to 180 degrees. So to find angle B, I can just take 180 minus 98 minus 43, and that should give me 39 degrees. So angle B is 39 degrees. And now we come to our law of sines. So to find the sides, all we know are the angles. So we're going to have to use the law of sines to help us find the sides. So maybe first, I want to find side A. So what I'm going to do is I'm going to set up my law of sines equation as follows. So to find side A, I know that I need angle A and side A. So I'm definitely going to use the first fraction from the law of sines. And now I need to decide which angle and side pair I have. So that's going to help me only have one variable I need to solve for in the equation. So if you notice, the only side we have right now is B, and we've already found angle B. So what I can say is this is equal to sine B over B. And I have all of the letters in this equation except for side A. So I'm going to go ahead and plug those in. So this is going to turn into sine of 98 over little a is equal to the sine of 39 over 22. And now I can solve for a. So I'm going to cross multiply, and I'm going to get 22 sine of 98 is equal to a times the sine of 39, and I can divide by the sine of 39. So I get A is equal to 22 sine of 98 over sine of 39. Okay, so notice what I've done here. I've started with my law of sines equation, and I've gotten all the way down to where A is by itself. So at this point, you can use your calculator, and be sure that your calculator is in degree mode, because notice our angles are all in degrees. So if we were to put this in the calculator in degree mode, we should get that side A is equal to 34.6. So I can go ahead and put that in my box. And now the last thing we need to solve for is side C. So this is going to be really similar, except instead of sine A over A, we're going to use sine C over C. So I'm not going to write out the whole equation again. I'm going to skip to the part where I plug in the numbers. So we'll have sine of 48 over C is equal to sine of 39 over 22. Okay, and once again, I'm going to solve exactly the same way that I did the first one, so maybe I can go ahead and skip to where C is by itself. So if I cross multiply and then divide, I'm going to get 22 sine of 48 degrees over the sine of 39 degrees. So on a test, what I would require you to show is that you have all the angles and sides plugged in, so I would want to see this step. And then if you can skip to this step, that's fine, as long as you write out where the side is by itself, or whatever you're solving for is by itself, before you use your calculator. Okay, so those two steps are really important. But if you need to write out all the intermediate steps, that's fine too. But I'm just saying, bare minimum, I need to see plugged in and then the letter by itself. Okay, so if we plug this into the calculator, in degree mode, we should get 23.8. So I can go ahead and complete my answer box with 23.8. Okay, so that's an example of the law of sines. So let's try another one where we're not given the picture this time. So in this next one, I'm told to solve the triangle, but all I'm given is a bunch of information and no picture. So I have angle A is 39 degrees, angle B is 105 degrees, and side B is 60. So what I'm going to do first is I'm going to draw my triangle. So this doesn't have to be to scale, just draw a triangle. Try not to make it like all sides the same, because that might confuse you, but other than that, you don't need to be too specific. So I'm going to go ahead and label this A, B, and C, and now I can go ahead and label the angles and sides. So I know that angle B is 105, I know angle A is 39, and I know that side B is 60, so that'll be down here. And this will be side A, and this will be side C. So let's go ahead and write down an answer box and then figure out what I need to find. So I have side A, side B, side C, angle A, angle B, angle C, and I'm going to go ahead and fill in the information I'm given. So I have 105, 39, and 60. So just like in the first example, it might be easiest to find the missing angle first. So let's see. The missing angle is C. So just like we did in the previous example, we know all three angles must add up to 180, so we can just start with 180 and subtract off the other two. And that's going to give me 36 degrees. So I know that angle C is 36 degrees. And now I need to find side A and side C. So I can do that with law of sines. So let's go ahead and find side A first, let's say. So I can do sine of 39 degrees over A is equal to the sine of 105 degrees over 60. So again, I'm going with the pair of an angle and side that I'm given. That's going to be what I set it equal to in my law of sines. So that's why I'm going with the pair 105 degrees and 60. So if we solve this for A, we're going to get A is equal to 60 times the sine of 39 divided by the sine of 105, which turns out to be 39.1. So I'm going to put that in my box as side A. And then I can do the same thing for side C, except this time I'm going to use the angle for C instead of A. So I know C is 36 degrees, so I can do sine of 36 degrees over C is equal to the sine of 105 degrees over 60. And if I solve for C, I'm going to get 60 times the sine of 36 degrees over the sine of 105 degrees, and that should come out to be 36.5. So I'm going to put that in for C. And that is how we solve the triangle. So I want you to note here that in this example, we were given two angles and a side. So this would actually fall into case 1, where we have AAS. Okay? So if on your homework, you're just given a list of given information, the first thing to do is figure out which case you're dealing with. So if you're dealing with any of the first 3 cases, then you can go ahead and assume you have one triangle and just solve the triangle and be done with it. What we're going to talk about next is if you have that case of 2 sides and an angle, you're going to have to figure out how many triangles you have first before you can just jump in and solve. So that's what we're going to talk about now. So next, we have the ambiguous case, which is SSA. So again, that's 2 sides in a row followed by an angle. So when we have this case, we have the height of the triangle is equal to B sine of A. So what this means is A is just any angle, and B is the other side. So here we're assuming your sides are A and B, and your angle is A, but it could be any combination. So I could give you any 2 sides and any angle, and you could rewrite this height formula for any of those combinations. Okay, so that's important to note. But anyway, we get one of the following 4 cases. So we could have no triangle at all, we could have a right triangle, or one triangle. So these are sort of the same thing. So it's basically 3 cases. Because in both of these cases, we're getting one triangle, or we could get 2 triangles. All right. And so we're going to do an example of each just so you see how to test for each one. So let's jump in and get going. So in this first one, the directions might say something like solve the triangles. Okay. And so notice here, we're given 2 sides and an angle where one of the sides matches the angle. So that's a big trigger to you that this is SSA. All right. So the first thing we're going to do is test for the height. So we're going to do the height is equal to B sine of A, since my angle is A. And so I'm just going to plug everything in. So I'll have 85 times the sine of 85 degrees, which comes out to be 84.7. Okay, so once I find the height, my next job is to compare it to the other side. So in this case, the other side that we didn't use in the height equation is this 15. So 84.7 is greater than 15, which is equal to A. So now what I'm going to do is go back up and let's see what happens when our height is bigger than side A, or whichever side is the side that you didn't use in the height equation. So I notice when H is bigger than A, we have no triangle. All right. So what this tells me is that this set of information gives me no triangle, and so I can stop right here. I don't have to solve anything because there's no triangle to solve. Okay, so that's an example of no triangle. So let's try another one. So in this next one, notice I've switched the letters up a little bit. We have side B is 22, side A is 12, and angle B is 42. So once again, we're in this SSA case because we have two sides and an angle whose letter matches one of the sides. All right. So the first thing we're going to do again is test the height against the side lengths and see what we come up with. So I'm going to start with h is equal to a sine of b. So notice how my letters changed. So my angle is just the angle that I'm given, and then the side that I'm going to use in the height is the side that's not my angle. Okay, so the side that is my angle would be b, the side that's not my angle is a. So we're going to have a sine of b in this case. So if I plug everything in, I get 12 sine of 42 degrees, which comes out to be 8.03. And so I'm going to compare this to side B. So now I'm going to compare it to the side that I didn't use in the height equation. So 8.03 is definitely less than 22, which is equal to side B. So when the height is less than B, we need to now test. We know that there's at least going to be one triangle, but we need to know whether there's one or two. Okay, so if the height is less than that side, we need to then test that side against the other side. So now I'm going to compare side B to side A. So B equals 22 is greater than 12, which is A. So when the height is less than B, but B is greater than A, this gives us one triangle. All right, so I know that I need to solve for one triangle, so I can go ahead and draw it. All right, so I've got angle A, angle B, angle C, and I've got side A, side C. Side C, side A, and side B on the bottom. So let's go ahead and label what we have. So B, we know, is 42 degrees, side B is 22, and side A is 12. So what I still need to find are angle C, side C, and angle A. So I'm going to have angle A, B, C, sides A, B, C. All right. So notice that this case is a little different than the ones that we did way earlier in this section. So since we only have one angle, we can't just right away find another angle by just using 180 minus the other two. So what we're going to have to do in this case is actually use the law of sines to get one of our other angles, because we have two sides, but to find the other angle, we can use this pair of angle and sides that we have, and we can complete the pair with angle A and side A. So let me show you what I mean by writing it down. So we can do sine of A over 12 is equal to sine of 42 degrees over 22. So notice I had that pair of angle B and side B, so that was one side of my law of sines. And then the other side I had side A, but not angle A. So we sort of have to solve for that one first. Okay, so let's see what we can do here. We can multiply 12 to the other side and get sine of A is equal to 12 sine of 42 over 22. And then I can take the sine inverse of both sides to get A by itself. So I get that A is the sine inverse of 12 sine of 42 over 22. So if I put this in the calculator, I should get that angle A is 21.4 degrees. All right, so I'm going to go ahead and write that in the box. And so now I can find angle C pretty easily. So this was the first thing we did. I'm going to start numbering the things that I do in order, so when you go back, you can look at that. So next we're going to find angle C. So angle C, I can do 180 minus the other two angles. So minus 42 minus 21.4, and that should give us 116.6 degrees. So I'm going to write that in the box. And then finally, I need to find side C. So now that I have angle C, I basically have everything I need for law of sines, right? Because I still have that pair of angle B and side B, but now I have one of the two things in that angle C, side C pair, so then I can set up law of sines. So I can say sine of 116.6 degrees over side C, which we don't know, is the sine of 42 over 22. So this is going to be solved similarly to those other examples that we did earlier in the section. So C is equal to 22 sine of 116.6 over sine of 42. And the calculator should give you that that is 29.4. So that's going to be side C, and that completes our triangle. All right. So notice that these side-side angle cases are much more complex than the initial examples that we did. So our first step is to test the height against the two sides, see how many triangles we have, and then once we know how many triangles we have, then we know what our picture should look like and what we need to solve for. So if you thought that that one was complicated, this next one is going to be even more so. So notice we've done 0 triangles, 1 triangle, so you should be guessing by now that this example is probably going to be 2 triangles. So let's see if that is indeed the case. So we have the height is equal to B sine of C. So notice in this case my angle is C, so I'm going to use the side that isn't C in my height equation. So I get 31 sine of 20.5, which is equal to 10.9. Now 10.9 is less than 12, which is side C. So I know I definitely have at least one triangle, but then 12 is again less than 31. Okay, so when I get this chain of inequalities, so I'm compared H to side C, and then I've compared side C to side B, and everything's less than everything else. So this tells me that I get 2 triangles. All right. So at first, it might be kind of tricky to remember what case you're in based on this height result, but the more you practice, and you'll find ways to figure out like which case you're in. A good thing is 2 triangles is when you get this chain of inequalities. 1 triangle is when that second inequality flips around, and then no triangles is when that first inequality flips around. You don't even have to worry about testing anything else. Okay, so anyway, in this case, we are indeed 2 triangles. So I'm going to explain how the picture goes for 2 triangles because it tends to be really confusing. So let me switch colors here because I'm going to need lots of colors for this. And I'm going to draw it kind of big. Okay, so we've got this big triangle going on here. And we've got this other triangle sort of, or we've got this line dividing the triangle like this. So what we're doing here is these are our 2 triangles overlapping each other, if that makes sense. So let me switch back to blue. And let me get a highlighter. Okay, so what we're going to say is we're going to say triangle 1 is going to be this big triangle on the outside. So this one I'm highlighting here. Everything that we write with a subscript of 1 is going to deal with that triangle. And I'm going to have this other pink triangle is going to be this one here. So part of it is going to overlap the yellow one, and part of it is not. So notice which triangle I'm highlighting here. A lot of people like to actually take this isosceles triangle, but that's not the second triangle. The second triangle is this obtuse triangle right here, so that has the big obtuse angle. So it's the pink and the yellow. Those are the 2 triangles we have to solve. Okay, so let's actually put some labels on this thing. So the way we want to label this diagram is the angle we're given always goes in the bottom left corner, because that's the angle that the 2 triangles are going to share. So we want to make sure that we put that there. Next, we want to put the angle of the other side that we have. So in this case, our other letter in the given information is B. So that angle is going to go on the right. So we're going to have angle B, and this is actually going to be angle B1. And then for the pink triangle, we're going to have angle B2. Okay, so once again, anytime I label something with a 1, that refers to the yellow triangle. Anytime I write something with a 2, that refers to the pink triangle. And if I don't write a subscript, then it's in both triangles. All right. Okay, so we have angle C and our two B angles. Our A angles then are going to go at the top. All right, so whichever letter you don't have in the given information, that's the angle that goes on the top. So A1 is going to be the top angle of the yellow triangle. A2 is going to be the top angle of the pink triangle. And then we just need to label our sides. So side B is going to be over here on the left because it's across from both of the angle B's. Side C is going to be over here on the right because it's across from angle C. And then this big side on the yellow, the yellow triangle along the bottom is going to be side A1. And this bottom side of the pink triangle is going to be side A2. Okay, so that's a complicated diagram. So when you're doing your homework on WebAssign and you come to any of these in section 8.1, make sure you're drawing pictures for all of these because it will make it make so much more sense. I remember when I was taking pre-calculus, this was the section I just did not like because it was super difficult. But if you can get the pictures correct, then the rest of the problem will be not so bad because you're just using the same equation a bunch of times. Okay, so now that we have our picture, and I guess I could go ahead and write in the stuff we have as well. So C is 12, B is 31, and angle C is 20.5. Okay, so now that I have my picture, let me go ahead and write my answer box. Where do I want to do that? I guess we'll do it right here. Okay, so we're going to have a few more things in this answer box than the other ones. So we're going to have side A1, side A2, side B, side C, and then we're going to have angle A1, angle A2, angle B1, angle B2, and angle C. So I have angle C is 20.5, side B is 31, and side C is 12. All right, so we have a lot of stuff to find, but I think I've got a pretty good way to do this where hopefully if once you do a few more of these, you get into the routine of like which order you solve stuff in. So with these, it's really important that the first thing we do is get angle B in the yellow triangle. So we're going to start by finding angle B1. And the way we're going to have to do that is using law of sines because we only know one angle. So we can't just take 180 and subtract stuff off because we don't know two angles. So we're going to start by doing the sine of B1 over side B, which is 31, is equal to the sine of 20.5 over 12. So if I solve this for B1, what I'm going to get is the sine inverse of 31 times sine of 20.5 over 12. And if I put this into the calculator, I should get 64.8 degrees. So when I solve for this first angle in the yellow triangle, it should always be an acute angle. Okay, so I should always get something less than 90 degrees, and 64.8 checks out. So I'm happy with that answer. So I have 64.8 degrees. Okay, so the next thing you can solve for is B2. And you could do a couple of different things actually from here, but most important is solve for B1 first, and then me personally, I just like to do the letters sort of all at a time. So the next thing I'm going to do is get angle B2. So we actually don't have to use law of sines again because the reason I drew this line here like this is that it actually creates what's called an isosceles triangle. So this side in blue is actually equal to side C, which is 12 highlighted in yellow. Okay, so what that tells us is that the two angles at the bottom are actually the same. So this angle is angle B1 as well as this angle. So angle B2 is this bit over here, which when added to angle B1 makes a straight line. Okay, so if two angles make a straight line, then we know that they must add up to 180 degrees. So to find B2, I can just take 180 minus B1, which is 64.8. And that should give me 115.2 degrees. So I'm going to write that in for B2. Okay, so we have our two B angles. So now I can actually finish this out and find both of the A angles. So I can find all of my angles first and get those out of the way. So third, I'm going to find angle A1, which we know two angles of the yellow triangle now. We know C and we know B1. So to find A1, I can just take 180 minus B1, which was 64.8, minus C, which is 20.5. And if I do that, I should get 94.7. So we get that. And then finally, I can find angle A2, which is basically the same thing, but I'm going to use all the angles I know about the pink triangle. So I'm going to take angle C again, but this time I'm going to take angle B2. So I'm going to do 180 minus 115.2 minus 20.5, and that should give me 44.3. So I'm going to go ahead and write that in the box. All right, so just like that, all my angles are solved for. So again, we had to start with B1, but once we got that, all the other angles weren't so bad. So the first one, you're going to have to use law of sines, but after that, you can basically use the fact that two angles that make a straight line add up to 180, as well as all three angles in a triangle add up to 180. All right, so now all we need to do is find sides A1 and A2. So actually, we're almost done. So let's say I want to find side A1 next. So what I'm going to do is I'm going to have to use law of sines again, but I'm not going to have to worry about any inverse stuff because we're just dealing with side lengths. So if I want to find side A1, I'm going to need angle A1, and I'm going to need a pair of an angle and a side that I know. So you could use either B or C, but I would prefer to use C because that was the stuff that was given. So the stuff that was given is always going to be more exact because remember these other answers we've been putting into a calculator and getting an estimate basically. We've been rounding. So what we're going to do is we're going to use the pair angle C side C and the pair angle A1 side A1. So we're going to say the sine of A1, which is 94.7, over side A1 is equal to the sine of 20.5 over 12. Okay, so if I solve for A1, that's going to be 12 times the sine of 94.7 over the sine of 20.5. And putting that in the calculator should give me 34.2. So I'm going to go ahead and write that in the box. And then finally, the last thing I need to find is side A2. So the very last thing, and I know these problems are long, but we're almost done. So for this one, I'm going to use the same angle C side C pair, and then I'm going to use angle 2 and side A2. So I'm going to have the sine of 44.3 degrees over A2 is equal to the sine of 20.5 over 12. So if I solve this for A2, I'm going to get 12 times the sine of 44.3 over the sine of 20.5. And if I put that into the calculator, that should give me 23.9. So that's my side A2. Okay, so that's it. We've solved both triangles in this two triangle case. So I know that that's a long problem, but I feel like if you take it step by step, you should be able to do it. It's just going to take a little bit of practice. So just to recap, we tested the height, which gave us two triangles. We drew this pretty complicated picture with two triangles. So practice doing that because that can get really tricky. And then we basically just solved things in a specific order that made it really organized. So make sure to always solve for this angle on the right first, but after you do that, you can pretty much get some other stuff in different orders, but if you want to go ahead, solve for all the angles first, then get those two missing sides. That'll help you not to forget stuff, all right? So that is the ambiguous case. So let's switch gears a little bit and go to a word problem, which also will use the law of signs. Okay, so we have Ron Swanson wants to construct a Swanson chair. So if there are any Parks and Rec fans out there, I hope you enjoy this. He finds a stately tree on a hillside near his cabin, which will suffice. The tree casts a shadow 215 feet down the hill. If the angle of inclination of the hillside is 22 degrees to the horizontal, and the angle of elevation of the sun is 52 degrees, find the height of the tree. So this sounds pretty complicated, but we're going to break it down, draw a picture, and see how this relates to the law of signs. Okay, so first of all, we have a hill. So we're going to represent that hill with a right triangle, like this. And we know that the angle of inclination, so remember from those word problems we did in the previous section, that angle of inclination means from the ground up to this hillside. So that's going to be 22 degrees. And now I've got a tree at the top of this hill, and I've got a sun up here somewhere, and the sun is shining light down off the top of the tree, and the tree is casting a shadow down the hill. So this is my tree, and that's my sunbeam is the dotted line. So the angle of elevation of the sun is 52 degrees. So again, angle of elevation is going to be the ground up to the line of sight, so up to the dotted line. So how am I going to draw this where it's not confusing? Do it in a different color. So I'm going to do this in red. So we have this angle here is 52 degrees. So the hill plus the hill to the sun is 52, if that makes sense. All right, and then let's see if we can get anything else out of this. Okay, the shadow is 215 feet long. So we have 215 feet is going to be this hillside where the shadow is being cast. Okay, so that's all we know so far. And we know we want to find the height of the tree. So what we're looking for is this distance right here, and I'm going to call that h for height. Okay, so let's see how we can use this to get something with law of signs. So I know the side is 215, and so maybe I should ask myself what angle's across from that side. Well, that would be this angle at the top here between the tree and the sunbeam. So I think I can figure out what that is. Let's see if we can. Okay, well, I know that this little angle in here is going to be 30, because that's basically the difference between the angle of elevation of the sun and the angle of inclination of the hill. So it's that little angle in between is going to be 30. And then let's see. If I use the bigger right triangle with the dotted line, the ground, and then that whole height there, I think that could work. So to find this angle at the top, we can do, so I'll label this angle between tree and sunbeam. So to do this, we can take 180 minus 90 minus 52. And that'll give me 38 degrees. So this angle at the top is 38 degrees. Okay, so let's see what we have now. Well, I have this angle at the top that's across from the 215 feet, and I also know that that little angle in the corner here is 30, and that's across from the height of the tree. So that's a really good setup. So now what I can do is actually set up a law of signs. So I'm just going to label this so when you go back, you know what we did. But of course, you don't have to label stuff for a test. I mean, a picture would be nice. I would expect you to draw a picture and label all of that, but as far as like labeling your equations, you don't need to do that. Okay, so we have the sine of 30 over that height is equal to the sine of 38 over 215. So again, we just set up two fractions, one fraction for each angle and side pair where they're across from each other. So now all I need to do is solve for h. So we know that h is 215 times the sine of 30 divided by the sine of 38. And if I put that into the calculator, I should get 174.6. So one important thing is, remember, when we do word problems, we always want to write the unit of what we're solving for. So in this case, the shadow was measured in feet. So since height is also a distance, we're going to use that same unit for our answer. So we get that the tree is 174.6 feet tall. So that's an example of a word problem, and there will be a couple of those in your homework. Okay, the last thing we're going to talk about in 8.1 is the area of an oblique triangle. So you're probably familiar with the very common area of a triangle formula, which is 1/2 times the base times the height. So what we're going to do is get a slightly different equation for the area based on the stuff that we've done in this section. So the big question is, how do we find the height of an oblique triangle? Okay. So if you remember from when we did our SSA case, or our ambiguous case, we found the height by taking a side times the sine of an angle. So let's say you know what, I'll zoom in for this so that we have it, we're not distracted by the two triangle case. So let's say that we have side C and angle alpha. Okay, then the height, so then we can say h is equal to C sine of alpha. So now that we have an expression for h, I can plug that into the original area formula. So then we plug this in for h. So what this does is this gives us a new area formula, which is 1/2 BC sine alpha, where A and B are two sides of our triangle and alpha is the angle between them. So just to give you a little picture, say that this is our triangle and we have side B and side C, then angle alpha, or A if you prefer that, is that angle that's in between side B and side C. Okay, so that's very important. So it's not just any old angle in the triangle, it has to be the angle between the two sides that you're using in the formula. Okay, so we're going to do an example. So we want to find the area of a triangle with sides A equal to 90, B equal to 52, and angle C equal to 102 degrees. And we want to round to the nearest integer. So the formula for area is 1/2 BC sine alpha, but in this case our two sides are A and B, so I'm just going to go ahead and write those. And we have the angle C instead of alpha, so I'm going to go ahead and write that in. So just a little check, let's make sure that we have the picture that we want. So we have angle C, we have side A, side B, this would be angle B, this would be angle A, and this would be angle C. So this looks good because I have angle C, which is 102, and that's the angle in between sides A and B. So this formula will work with what we have. So now I just need to plug everything in. So we have 1/2 times 90 times 52 times the sine of 102 degrees. And if I put that all into the calculator, I should end up with 2,289. So it's just a large number because 90 and 52 are pretty large numbers. So it's okay to get something that big. In this problem, we didn't have units on the side lengths, but I will make a little note just in case in your homework we do. So we're going to make this a little thought bubble at the bottom. So if the side lengths have units, so just as some examples, those might be centimeters, inches, feet, etc. Then the area has units, centimeters squared, inches squared, feet squared, etc. So whatever the unit is for your side lengths, the area's unit must be that unit squared. Okay, so area is always a squared unit. Lengths are a one-dimensional unit, so we don't have an exponent on those. So that's just something important to remember. Again, in this example, we didn't have units, but if your problem on your test or your homework has units, you would be expected to put that. If WebAssign does not put it for you already, on a test, you would definitely be expected to write it out. All right, WebAssign may write it for you. So anyway, that is the end of section 8.1. If you have any questions, please let me know because some of this stuff can get really tricky.